case, the object we're talking about is commits. You take commits, and each commit represents some status of the code. Each commit has its own files, and work has been done on those files. They contain some content, and you want to take the content of those files and you want to merge them together so that the changes that have happened on this side and the changes that have happened on this side are both reflected in the merge. So let me bring up the slides again. So what I wrote on the slide was merging is how you take the work done in different commits and you combine it into a new commit, which integrates the work in those previous commits. And we'll see what that means. Now, a very common part of the workflow in Git is that you have, remember we talked about this, topic branches, these short-lived branches, which is where you do work, where you integrate, where you actually develop features. And then when the features have been developed in the topic branches, you integrate that code into the long-lived branches, the master or develop branch. So merging is usually how you take that feature that you've developed, take that code, and you fold it into the main line, the main line of development. So in Git, merging is something that's done to branches. Remember I said that you actually take the content of two commits, and that is true. Commits are at the core of what the merge command will apply to. But the merge command actually operates on branches. Remember that a branch is just a label that you put in a commit. So when you merge two branches, what happens is you take the head of those two branches that you merge together, and those are the commits that will be folded together, merged together into a new commit. Before we look at merging in its absolute generality, we're going to look at a very simple case. We're going to look at the base case of how merging can be done. And that's the case when there's a linear path from the branch that you are on to the branch you want to merge. We're going to look at this in real life. We're going to look at an example of how this works. So if this seems a bit abstract to you right now, don't worry. I'll show you what this means. If there's a linear path from the branch you're on to the branch you want to merge, then we say that a merge is fast forwardable. And let me show you a Git commit graph where this is the case. Here is a very common situation. You have a master branch. This master branch has 3 commits on it. Can you see that? To the left, there are 3 commits in the history going from the head of master. And just to reiterate, remember that the head of a branch is the commit that the branch points to. So that blue commit on this graph, that's the head of master. And what's implied in this diagram is that if you go from right to left, that's going backwards through the history. So on the master branch, there are 3 commits. Then at some point, someone created a feature branch and they continued the work. So we now have 2 more commits after the head of master. As you can see here, there's a very linear path going from the latest commit on master, the head of master, to the head of that feature branch. It's essentially just a single line. So when you're saying that, I have done some work, which is on the feature branch right now, and I want my master branch to contain that work. That's basically what you're saying when you're doing git merge. Well, the simplest way of doing that is basically saying, this history is nice and linear. You started from the master commit, the head of master, and you added some work, and you added some more work, and now you're 2 commits ahead of me. So in order for me to get the work that you've done now on the master branch, all you basically have to do is to move the label. Like so. Does that make sense to you? What we've done now is we've taken the work that's in the feature branch, the one labeled some feature, and we've integrated all that work into the master branch. All we had to do was just to move that label. Any questions about that? We're going to have a look at the real life example of how this works in a minute. But what I want you to remember is that in this case, when there's a linear path going from the head of the branch that you want to merge into to the head of the branch that you're merging, that's called a fast forwardable merge. And this is what it looks like. And whenever a merge is fast forwardable, all Git wants to do is just to move the label of the branch. It's very simple. There's nothing more to it. A fast forwardable merge is the simplest possible case. Now, of course, in some cases that will not be true. In some cases, you're not going to have a linear path going through history. Look at this diagram, for example. Here, the master branch has proceeded beyond the place where the feature branch branched out, right? The third commit from the left, that's where the feature branch sort of sprouted out. And you got 2 more changes from that commit. But then someone made a change on the master branch again, and the master branch proceeded. And so now the head of the feature branch and the head of the master branch, they're not part of the same history anymore. They've forked. You can see that on the diagram, so to speak. It's very visual what has happened. There's no clear linear path going straight forward. Basically, in this case, you'd have to sort of undo the work that the latest commit did on master to go back to the previous commit and then go out to the feature branch in order to create a path. Well, no, that's not possible. So in this case, of course, Git actually has to know how to integrate different lines of work. And what happens is that in this case, Git will force you to create a new commit, which is the blue one on the very right side of the diagram here. You will be forced to create a new commit. And Git is going to try and be smart. Whenever you say to Git, I want to merge the feature branch into master, and that merge is not fast forwardable, Git is going to look at the 2 commits, the 2 heads, the head of the master branch and the head of the feature branch. And Git is going to say, oh yeah, okay, so we have 2 different working directories here. And we have file A in this commit and we have file A in this other commit. And those differ by a few lines here and there. Now Git has some very sophisticated algorithms for trying to figure out which lines that you should keep from the one commit and which lines to keep from the other commit. And sometimes it manages to do everything completely automatically, in which case Git will just create that commit for you, that merge commit for you, and then it'll move the label. Then it'll move the master branch to the newly created commit. You have now integrated the work into the new commit. However, a lot of times Git won't be able to do everything automatically. There will be some ambiguity as to what should be kept and what should not. And in that case, you have a merge conflict. And Git is going to tell you, oops, I can't do this for you completely, but it'll tell you which files that you need to actually reconciliate and look through to manually pick out what to keep from the feature branch and what to keep from the master branch. And then you manually pick out the code you want to keep from each branch, and you tell Git, okay, I've solved the problem. And once you've told Git that, it'll create the merge commit, and the same thing happens. The merge commit is created and the master branch is moved. And the end result is that you've now integrated work from two different branches, and you have a new merge commit with two parents. And Sydney is absolutely right. This diagram should say after merge. It says before merge on both diagrams. Oops. You're absolutely right. This diagram should definitely say after merge. This is after the merge has been done. Very sorry about that. That didn't mean to confuse you. This is after the merge has been done. Now, I won't go into great detail about what Git does in order to figure out what code to keep and what not to keep, or at least it tries to do that. But I just want to point out that what Git has to do in order to make an intelligent and reasoned choice is that Git looks at the common ancestor of the two commits that you're trying to merge. As in, it looks at the heads of the two branches you're trying to merge, and it'll find their common ancestor. Because they will have to have at least one common ancestor. I mean, at some point you had an initial commit in your Git repository, and everything comes from that commit. So there's at least one common ancestor, namely the initial commit of the Git repository. But there might be a later one. So it looks at the first common ancestor it can find, and then it'll compare the files in each of the heads of the two branches that you're merging to the common ancestor. And that's why Git merge function is referred to as a three-way merge. So basically, this is what it does. You know, if you're merging feature here into master, it goes back throughout the graph to find the common base, the common ancestor, and then it'll compare the files in the feature to the common base and the master to the common base. And it can look at things like, you know, this line was changed on one side and it was kept the same on the other. And then it can react on that. Before we actually go ahead and run an experiment on our own computers, and we do this in real life, there's one thing I want to point out, and that is if a merge is actually fast forwardable, you can force Git to create a merge commit anyway, not just move the branch, but to create a merge commit by using the noFF flag. Git merge --noFF is going to force the creation of a merge commit. So if you look at this situation, you have two commits, presumably on a master branch, and you have two green commits, presumably they were on a feature branch. Now, if master was at the second of those commits from the top, and the feature branch was on the second of the green commits from the top, then in that situation, you should recognize that as a fast forwardable commit. And if you merged feature into master, you might expect just the master branch to move to the second of those green commits. But if you do merge with the no fast forward flag, you can force the creation of a merge commit anyway, in which case that merge commit will be identical to the second green commit. And the reason you might want to do that is because you might want to keep the Git graph in that shape in order for you to know exactly which parts of the graph were part of a feature and a feature branch, and you might want to keep the merge commits as an explicit sign that here a merge happened, and this is code that is deemed shippable and deployable. And if that doesn't make sense now, we'll look at this again later. Now I actually want you to bring up the terminal. In fact, let me bring up a terminal and a diagram so we can look at what happens to the graph. Now hopefully you should see a diagram on the left side of your screen, and you should have the terminal on the right side of your screen. Is that correct? And I'm just going to create a new directory where I'm going to initialize a repository. And I would like you to do the same as well. So please tell me when you've created a new directory and you've initialized Git repository. And I hope you're still with me. You still there, guys? We haven't had another blackout, I hope. Can you see the diagram? And can you see the terminal? And is everything legible? Maybe I should move the terminal down a little bit. Okay, done. Is everyone done? You have a new directory with an empty Git repository initialized. Terminal's a bit small. Okay. Let me try and increase the font size a little bit. Let me see what we can do. Font size 12. What about 14? Oh no. This OBS always does this for some reason. Let me try and switch it to here. Let me see. Okay, is that readable? Is that better? Hopefully that should be a bit better. Okay, very good. Now we have an empty Git repository, and right now we actually have no commits. And although it says we have a master branch, we don't really, because it's not pointing anywhere. So the first thing we're going to do is to create our first commit. And we'll do that by simply creating a file. Roses are red. I'm going to put that into poem.txt. And we're going to add that file to the index. Remember, if you don't add it to the index, Git won't know about the changes. It won't actually save the changes that you've made. The index, everything has to go onto the index. And what's on the index, well, everything you want to keep has to go on the index. And a commit is created from the index. So once that is done, we're going to create our first commit. We'll just call it initial commit. Or we're going to use the commit message initial commit. And we've now created an initial commit. And in my case, this commit has hash 9541, etc. Yours is going to be different because you have different names than me. You committed at a slightly different point in time, etc., etc. So the commits are going to be different. But mine is called 95416F, etc., etc. So right now, at this point in time, my commit graph looks like this. This is the initial commit. And my master branch is here. Okay? Are you with me? Now, if you actually want to look at the commit graph, and this is something you might want to do a lot, use git log -- graph. That'll actually show you the commit graph. And right now, as you can see, we have one commit here. This is the hash. This is where the master branch is at. The master branch is at this commit. And this is the commit message. Now, can everyone just tell me when you've reached this stage? You've created a commit, and you can verify using git log -- graph that your repository looks like the diagram to the left. You have a single commit, and that's where master is. Now remember head with capital letters. That's the name of the branch that you've currently checked out into your directory. So head points to the branch that is checked out into your working directory. Capital head, that is. Head with capital letters. And master is where head is pointing to. So this diagram is saying that right now we've checked out the master branch, and the master branch is currently at this commit 9541, etc. In my case, in your case, the hash is going to be different. Now, if this is a bit verbose, and it might be, just use git log -- line -- graph. That'll just summarize everything in a single line. And I think that is much neater going forward. So I'm going to do that from now on. I'm going to just use git log -- line -- graph. And that'll show us the commit graph with one line per node in the graph. So try that on your computers as well. Just run git log -- line -- graph. And once you've done that, we're going to create a new branch. Sydney's asking, what is the significance of head being in all caps? So this is just a naming convention in Git. Remember, I talked about head in a different context. I said that the head of a branch is the commit that the branch points to. However, in Git, they're also using the letters head in capital letters to mean the branch you've currently checked out. So the significance of head being in all caps is that whenever head is in all caps, we're actually talking about the currently checked out branch. I think it's a bit confusing at times, but whenever you see head with capital letters, it means the branch you've currently checked out. And whenever we talk about the head of a branch, in just ordinary parlance, the head of a branch, we're talking about the commit that that branch points to. I hope that doesn't trip anyone up. Now, at this point, we want to create a new branch. And we're going to do that by running git checkout-b. And sometimes commands in Git are a bit confusing. This will create and check out another branch. Git checkout-b. The -b flag is what will create a new branch for us. And let's call this branch feature. Okay? Now remember, the -b is what actually creates the branch for us. if you run git checkout without -b, it will look at branches that are already created and try and find it. Actually, let's try and do that. Let's just do git checkout feature. We haven't created another branch. We're just trying to check it out. In that case, it'll tell us that feature doesn't match any files known to Git. The branch doesn't exist. However, if we do git checkout -b, now we've created a feature branch and we've switched to it. And what has happened to the diagram? Well, this has happened. We now have yet another branch called feature. And it still points to the same commit. It points to the commit that we were at when we created that branch. Can you now run git log _one line _graph and verify that your commit graph looks something like this? Head now points to feature. Feature and master are both at your initial commit. So in other words, the graph is like it is on the left. In the diagram to the left. We have one commit, the initial commit, and now we have two branches. And is everyone with me? Is everyone caught up? Peter and Dibwe, maybe you could check on the recruits and tell me where everyone's at. And if everyone is stuck, if anyone is stuck, or if we need some more time, then just tell me. And just give me a heads up if everyone's ready. And lots of you are still here and you're with me, and that's very good. And do check on your fellow classmates and see how they are doing. And if anyone is not where we're supposed to be at, then do help each other. And I'll wait for either Peter or Dibwe to tell me that everyone's at the same page. Yeah. So, Peter, Dibwe, where are we at? I hope that they're now going around checking everyone's computers to look at where we're at. Are they? Or is everyone just sitting there right now waiting for me to continue? Yeah, what's happening, guys? Please continue. Okay. In that case, we're now going to modify the file a bit. So open the text file that you created in whatever text editor you're comfortable with. I'm using Vim. Some people might use Nano. Some of you might use Sublime Text. or Visual Studio Code, or whatever you're comfortable with. And we're going to improve the poem, or write whatever you want. Just make some modifications to this file. Okay? Something like this. Just make some simple changes. Save it. And add it to the index. Now, write something for the commit message, whatever you want. Finish poem. There we go. Now, what did we do? We made some changes to the file. We committed those changes. And by doing that, we created another commit. And what does the graph look like now? Finish poem. This, in my case, is commit 9743, etc. Yours is going to look different, of course. And since we were on the feature branch when we committed, the feature label comes along with it. And of course, the parent of this commit is the initial commit. Because the initial commit was checked out, we made some changes to it, and the new commit gets the old one as its parent. So now the commit graph looks like this. And if you run git log -- line -- graph, hopefully your commit graph should reflect that. We now have the initial commit at the bottom, and that's where the master branch is at. And we have the feature branch up top as the child of the master commit, the commit on the master branch. So if you run git log line graph, it should look as on the screen, and the corresponding diagram is the one on the left. Does this make sense to you? So, if it's a bit confusing that you can't actually see the lines between the two commits in the graph, you can remove the one line and you'll see that if you do the full git log with the full graph there, you'll see that these two commits are connected by a red line here. Well, it doesn't have to be red, but it's connected by a line to the left. So, okay. Now, if I want to integrate the work that has been done on the feature branch into the master branch, is this a fast forwardable commit? Is this a fast forwardable merge, or is it not? If you look at the commits, if you look at the heads of the master and the feature branch, does this look like the merging feature into master would be a fast forwardable commit? I'm really messing things up. Is it a fast forwardable merge? I'm sorry. Merges are fast forwardable, or they are non-fast forwardable. Is this fast forwardable was my question. And I'll try not to I'll try not to mess up the terminology anymore. And some of you seem to be saying yes. And that is true, because there's a single path going from the master branch, and towards the commit that we want to merge. It's a linear path, it's a straight line, there's no branching out here. So we're now going to try and actually merge the feature branch into the master branch. That means we're going to take the work on the feature branch and we're going to fold it into the master branch. Sydney is saying that I think it's fast forwardable, and yes, you are right, it is fast forwardable in this case. So what we're going to do is we're going to run git checkout master in order to check out the master branch. Okay? And you should now be on branch master. Now we're going to tell Git to integrate all the work that has been done on the feature branch. And you're going to run git merge feature. And it'll tell you it's updating. Then it'll tell you this is actually a fast forward. And the poem.txt file has now changed. When you integrated work from the feature branch into the master branch, the poem.txt file was updated. Well, it had to be, because we made some changes to it. Now, what we are going to see is that since this is a fast forwardable merge, all that has happened is that the master branch is now moved up here. And let's have a look at the log. Git log -- one line -- graph. What does that tell us? There we go. That is exactly what we got on the left hand side. Now tell me if you've been able to replicate this or not. So what does this mean? It means that if someone now checks out the master branch, what they're going to get is the poem.txt file that looks as follows. Roses are red, babies are choosy. This is a shout out to my friends at Umuzi. That's all the work we did in the feature branch. That work has now been integrated into the master branch. The commit that master points to now contains the work that was originally on the master branch, as well as the work on the feature branch, and integrated it. And where the master branch is now, that is the commit that integrates all that work. Okay, but now we're going to backtrack a little bit. Now we're going to reset the graph a little bit. We're going to make some changes to the graph, and we're going to do things a little bit differently. Okay? So we're now going to undo the changes we just did. We're going to move master back to the initial commit. Okay? And whenever you move a branch, you're going to use the git reset command. So you're going to run git reset. First of all, just make sure you're on the master branch, because we're moving the master branch, so make sure that that is what is checked out. And in my case, I can see that because in my prompt to the left, it says master. If you're not sure what branch you're on, let me just clean the screen a little bit. If you're not sure what branch you're on, you can run git status, and it'll tell you that you're on branch, and then whatever branch you're on. And all of you should be on branch master, and if you're not, you'll run git checkout master. We're now going to move the master label, and we're going to do that by running git reset. And we're going to not just reset the branch, but we're also at the same time going to check out the commit that we're resetting master to. And you do that by adding hard, --hard. And then what we're going to need is the hash of the commit you're resetting to. Sydney is also saying that you can type git branch to see what branch you're on, and that's absolutely true. You can type git branch to see the branch you're on, and also the names of branches that you have locally, because you might have more than one. Now, going back to what we're doing, we're going to reset the master branch. We're going to move the master branch back to the original commit. And you do that by running git reset hard in order to check out the commit into the working directory when you move the branch, and then the hash. And you just need the first few characters of the hash, and that'll be enough. As long as Git can recognize the hash uniquely based on the first few characters, you're good. And we've moved the branch. Now, if you don't remember the commit hash, use git log. Git log will show you the hash. And what we've done now is to actually move master back here. We've undone the merging, so to speak. This is a command that you should know about. It's very useful. Sometimes you make a mistake, you merge something by accident. You should know how to reset your work, to go back to where you were at. And when it comes to resetting branches, moving branch labels back to where they were at, git reset is what you're going to use to do that. So tell me when you've moved the master branch back to the initial commit. When you've done so, your graph should actually look like this. Now this is interesting because when you do git log one line graph, you can't actually see the other commit that's in the repository. So most of you at this point should have a git log that looks like this. And please verify that you do. Some of you might have changed the settings of Git to show everything at all times, but I think most of you will now at this point see only one commit in the Git log. Oh, you're asking what hash are you supposed to use with git reset hard? If you don't remember the hash of your first commit, run git log. Git log will show you the commits that you have in your commit graph, and it'll show you the hash of that commit. So if some of you were not able to find that commit, let me go through this process with you again. Let me go back to the situation we were at where the master branch was merged. So I'm going to remerge my master branch now. I'm going to remerge feature into master. Merge feature. Okay, now I'm back here. I'm back before all this resetting happened. Right now, at this point, my graph looks like this. My git graph is displayed to the left here, and as you can see, git log shows that that is indeed my graph. Now I want to reset master to the first commit. And if you run git log, you can find here the hash of the initial commit. I'm copying that, and I'm then running git reset hard, and then the hash of that commit. And when I've done that, head is now at that commit. So Sydney's asking, so we're resetting the master branch, therefore the command is git reset -- hard hash of the initial commit. Yes, we're resetting the master branch. And the way Git knows that that is the branch we're resetting is because that's the branch we've checked out. And when you've checked out a branch and you run git reset -- hard and then a commit hash, the branch will be moved to the commit with that hash. So right now, after I've run git reset hard, my commit graph looks like the diagram to the left. Are you still with me, or is it confusing? If we now check the file in our working directory, poem.txt, you'll see that that's the file that was checked in with that commit. Just roses are red. That's the file we checked in with the initial commit. So maybe I should even maybe I should bring in an arrow here to show what commit we checked out as well. Right now, this is the commit that we've checked out into our working directory. In fact, let's do it this way. This is head, capital head. Head shows you which branch is checked out. Right now, this is what is checked out. Okay. Is everyone on the same page? Has everyone reset their graph now so that the master branch is back at the first commit? Now again, now that we've checked out master, if you run git log one line graph, you can only see the commits that are reachable from master. If you want to see everything, you can add -- and you'll see everything, even the commits that are not reachable from master. But by default, git log is only going to show you the commits that are on the branch that you've checked out. That means the head of the branch you've checked out or its ancestors. Okay, now we're going to again modify the file, the poem. We're going to modify it in any way that you see fit. Just make it different from what you did on the feature branch. Roses are red. Let's do the boring thing. Violets are blue. Okay. Now we're going to add the poem to the index, and we're going to create another commit. Git commit. Okay, what has happened now? Well, we've created yet another commit. In this case, mine is called 70438. And we were on the master branch when we committed this. So this is where the master branch goes. This is what is checked out. And it has the initial commit as its parent. So this is what things look like now. And if you run git log graph, let's do all so we can see everything. that's what you should get. The initial commit is there at the bottom. Then you can see feature sort of forks out there on its own. And master is there by itself as well. You should see that the printout from git log corresponds to the diagram to the left. Does this make sense to you? And Peter Dibway, is everyone following this? Or is this confusing? Seems like it. Well, that's good. That's good. How are you doing, guys? Tell me if tell me if you're at the same place as I am. So right now, just to check what poem.txt looks like, roses are red, violets are blue. All right, now what happens if we try to merge feature into master? Is this a fast forwardable merge? Yes or no? Is this a fast forwardable merge? The graph should immediately tell you that something has happened to the histories of the feature and the master branch. They've sort of gone in different directions from the initial commit, from their common ancestor, at which point the city says that you think it is, and Sydney's saying that you don't think it is fast forwardable. And in this case, it is not fast forwardable. There's no way of getting directly from the master branch to the feature branch without going backwards through history first. There's no way forwards through history directly from the master branch. And that is because, as you're saying, the graph is not linear, as in you have to go backwards through history and then forwards again. If you can just go forwards in history, then it's fast forwardable. But in this case, we have to go backwards, then forwards. So it's not fast forwardable. Basically, we started out here and someone did something. And at this point here again, someone else did something else. So right now, these could have changed in very different ways. And now, in order to integrate the work on these two branches, we'll actually have to do a compare and try and figure out what to keep from each of them and what not to keep. So while we're at the master branch now, run git merge feature again. And what happens? You're going to be told that there's a conflict. And yes, of course there's a conflict. And this is a very common part of using Git. You have to just get used to conflicts. Conflicts are just Git's way of telling you that I wasn't able to do things fully automatically for you. So you have to help me a little bit and tell me what to keep and what not to keep. So it's saying it tried to auto merge poem.txt. There's a merge conflict. It didn't figure out what to do, and therefore the automatic merge failed, and you have to fix the conflicts. So open up poem.txt or whatever you call the file in your text editor and have a look, and you'll see that Git has inserted some special symbols. It has inserted a lot of less than signs with a capital head at the end of it, which is saying that head, that is what you had checked out in your working directory, that's here. And then there's going to be some equal signs. So between the head marker and the equal signs, that's what was in your working directory. And then between the equal signs and the greater than signs with the name of the branch you're merging in, that's going to be lines that came from that file in the other branch. And Git is telling you, you know, this is what I saw on one side, this is what I saw on the other side. You need to help me and tell me if I can, you know, keep everything or if anything should be done to this. And sometimes you might want to keep everything. Sometimes you might have to do some manual changes to the code. In this case, we're going to remove line 2 entirely. And once you're done editing the file, you should have a file that is now looking the way you want it to look. In this case, we basically undid the changes that had happened on the master branch. We just decided to keep what was on the feature branch. It didn't have to be that way. We did it that way because we have to tell Git how to integrate the work whenever Git whenever Git isn't able to figure that out automatically. So once you're done reconciliating the conflicts, save the file. And once you're done, you have to add the file to the index to say, you know, I'm done. I've fixed the conflict, and you can then use git status to check if there's any other conflicts left, and git status says all conflicts fixed. Okay? Well, in that case, it says use git commit to conclude merge, and that's what we're going to do. Git commit. And Git just creates a standard commit message for us. We can choose to change it, or we can choose to keep it the way it is. We're just going to keep it the way it is. Save the message. And now, what has happened? We have a new commit. A merge commit. And on my computer it has #99 etc. Now this commit has two parents because it integrated work from this commit and from this commit. And we were on the master branch when we merged, so the master is what moves. And this is the branch that is checked out still. Whoop. So this is what the commit graph looks like now. And if we look at log, you should see that the last commit in the log is now a merge commit, and it has the feature branch, the feature commit, and the initial commit as its parent. And that is how we integrate work in Git. So, tell me when you get to this point. If we now check the content of the file, This is the exact content of the file. Remember, we decided how to resolve those conflicts. This is what we decided to do. So this is now the content of the merge commit. Did that make sense? Are you able to resolve the conflicts? Remember, in order to resolve the conflicts, just open the file in a text editor and look for the places where GIT indicates that there's something that has to be manually inspected. And then you have to use your knowledge about the code or your knowledge about the file in order to figure out what to do. And once you've made your changes, you add the file to the index. You tell GIT, yeah, I'm done. I've fixed what I had to fix. There might be more than one file. GIT will tell you which files need to be edited, need to be well, have conflicts that need to be resolved. And once you've added all of them to the index, GIT will tell you, all right, we're done, you can continue. And assuming you're still having an unresolved conflict, okay, run git status to figure out what file that unresolved conflict is in. If it's a file that you have edited, then remember to add it to the index by running git add and then the file name poem.txt. Okay, run git add poem.txt, and then it will be added to the index. Then you've told GIT that I've resolved the conflicts. It says both modified. Yeah. That means that GIT recognizes that the file has been modified in both branches. If you open poem.txt in a text editor now, you should be able to see that there are some lines there that come from one branch and some lines that come from another branch. And then you just edit that file to decide which lines to keep. Once you've edited the file, run git add on the file, and then GIT will know that you've made the necessary changes, and GIT will trust you. At that point, GIT should tell you that you've resolved the conflicts. So how's it going, guys? And I'm trusting the instructors to go around and having a look. So, right, if you've edited the file and you've added it as well, then you should commit. Because once you've edited it and resolved the conflicts and added it, GIT will then know that you have made the necessary changes and you should be allowed to commit. Then the commit was successful. That's great. Now run git log to have a look at your commit graph. How's everyone else doing? I mean, I think we're past the end of the class, so we should definitely try and wrap things up. But it'd be very nice if we just got everyone through and made sure that all of you have been able to successfully merge the two branches. So Sydney is saying you need to add it first before committing, and that is absolutely correct. You have to add the files to the index in order to tell Git that changes have been made and these changes are ready to be committed. So you make a change, you reconcile the differences, then you add the file to the index, and then you can commit. That's always the workflow in Git. You make a change, you add the file to the index, and once you're done adding all the changes, all the files that go into that commit, you can create a commit. So is anyone stuck? Or is everyone been able to actually merge the two branches and create a merge commit? Where are we at? Everyone's with me. That is great. That is awesome. That means that, oops, we've all now been able to see what branches are conceptually and how you actually integrate work from different branches in Git. And once you know how to create commits and how to merge commits, and you understand what they conceptually do, you're really in good shape, because this is what Git is mostly about. The rest is about conventions. It's about, well, when do we create a branch and when do we merge? But this is the main sort of workhorse. This is these are the commands you'll be using. You're going to create commits and you're going to merge branches. Well, create commits, create branches, delete branches sometimes, merge branches. So for those of you who've used Git without using branches or merging branches, you've only used, you haven't used Git to its full potential. Branching and merging is what makes Git the powerful tool that it is. And it's what enables us to work together on a huge code base, many people on large teams at the same time, and where people can write one part of the program separately from another, and we can integrate that work later on. It's one of the most important things to know about in Git. And we've now seen it, and you'll have more of a chance to work with it in greater detail later on. But yeah, so this has been a really long class. Sorry for stretching it this long. We had a power outage, but you definitely deserve a break now. I'm really sorry for going on for this long. Thank you very much for showing up for class today. And we're going to continue with this material tomorrow. And I guess I'll see you again then. So yeah, unless there are any questions. Are there any questions? None. Okay, thank you very much, guys. I'll see you again tomorrow. Bye-bye.